Finally, let's try to test one of these analog and capture it. To that end, I'm going to bring a particular analog sensor. This is a heartbeat monitor, and you can just put it on your finger like this, and it can detect your pulse simply by the amount of light that gets reflected. There's an LED on the other side and a hole here, so based on the flow of blood in your hand, the reflection of the light is changed. Anyways, this kind of sensor is an analog sensor because its output actually varies. It has values ranging between 0 and 5 volts depending on the amount of light that got reflected. So if I plug in, let's say number 3, I will notice that the software has detected this, and as you can see here, the output of that monitor is changing. So if I put my finger, you will see that it starts picking up various values. It's sampled at a high rate, and the various values are changing. So the point is, unlike digital inputs that give us just one value, you can see here the value changed from 300 to 297. These are not voltage values. These are just scale values that shows how the input is changing on the input line coming from the sensor at various times. All right. As a second example of an analog sensor, I have here a glove with some flex resistors attached to each finger, and these resistors are made of material that changes its resistance value depending on how you bend it. So it has some value here and it has a different value if it's bent like this. So again, if I connect the output of that sensor, let's say to number 5 here, I'm going to put it, we'll see that analog input number 5 has changed its value depending on how much I bend that finger. And you can see that here the value is not changing continuously like the heart monitor. At this level, it's, as you can see here, it's 668, whereas if I flex it, it moves to 400, 500, and so on.